Hi everyone. Let's take a look at the following example. In gym class, a 62 kilogram student climbs up a 8.5 meter rope at a constant 2.1 meters per second. Part A. Calculate the time it takes for the student to climb the rope. So if we start with the given, we have the mass of the student, which is 62 kilograms. We also know that the displacement here is going to be 8.5 meters. Now, because the velocity is constant, this implies that V1 or V2 are both equal to 2.1 meters per second. Now, why is that useful? Because now, if you think about part A, your goal is to solve for the amount of time, which implies, in this case, you can think of displacement, which equals to V1 plus V2 divided by 2, multiply by time. And of course, you can either plug in the numbers or you can solve for time first. It's totally up to you. If you isolate for t, you would discover that time equals to 2 times displacement divided by v1 plus v2, which means in this example, the displacement is going to be 8.5. The velocity is 2.1. So 2.1 plus 2.1, of course, you can put all the units back in, but it's going to be in terms of seconds. And if you grab the calculator and you work it out, this is going to be approximately 4.04761948 seconds. And of course, if you look at the number of sig figs, it's going to be 2 sig figs. So you can round this to 4.0 seconds. Now, of course, you can write down a final statement. I'll leave that to you. But it's going to be, therefore, the time about 4.0 seconds. Now, if you continue with part B, calculate the power. What that means is you're looking for P, which stands for power. And in this case, what you have to do is this. Think about power as the change in energy divided by the change in time. And of course, if you look at the context of this question here, the change in energy is really, in this case, potential energy, which is m times g times h divided by t. And again, if you go back to the given, we know m is going to be 62 kilograms. Gravity, you can use 9.8 or 9.81 times the height, which is going to be 8.5 meters, divided by time. And again, in this case, I can use 4.04761948, just like that. And let's grab the calculator and work it out. So in this case, it looks like it's going to be approximately 1,277.262 joules. If you rewrite this in terms of sig figs and in terms of kilojoules, this is approximately 1.3 kilojoules. And of course, you can also write down the final statement. So in this case, you can type in, therefore, the power is about 1.3 kilojoules. If you find this video meaningful and it's adding value to your life in physics, please consider to comment, like, share, and subscribe. I hope this makes sense.